So now we're going to take a look at proteins. So proteins are not really going to be used for ATP production like carbohydrates and lipids are. Instead, they're going to have several other roles in the body. So they're used as signaling molecules. For instance, we have a lot of protein-based hormones and protein-based growth factors. They're used for the production of antibodies. They're used to help produce membrane receptors, membrane pumps, and certain ion channels or transport channels within membranes. Some proteins are used to produce hemoglobin and used within muscles to help with muscle contraction. Some of them are used as enzymes to help speed up chemical reactions, and some of them are used to help provide structure to certain organs within the body, like our skin, our hair, and our bones. So again, these are not going to be used typically for ATP production, but they're going to have several other very important roles in the body. Now, protein is going to make up about 12 to 15% of the body's overall mass, and 65% of that protein is going to be found primarily in skeletal muscles. And typically, the higher your metabolism is, the more protein intake you need to be bringing in. So, for instance, infants and children are going to need more protein than higher or older individuals because they have a higher, faster metabolism, and so they're going to need to be able to produce more fuel, and they're also going to need this protein for growth and development of certain tissues and organs within the body. Now, amino acids are the substances that we are trying to get from proteins when we digest them and break them down, and adult humans can synthesize 12 of the 20 amino acids that we need to stay happy and healthy, but there are some that we cannot produce, and so these are essential amino acids and ones that we have to get from our diet, from the foods that we eat. And we can't store these amino acids, so we have to get them in our diet every day. Now, complete proteins are ones that we can consume that will provide all of the 8 essential amino acids that we need, and these are going to be found primarily in animal products. So meats, for instance, are going to be complete proteins. They're going to have all the essential amino acids that we need. Incomplete proteins are ones that still give us essential amino acids, but they don't give us all of them. These are typically plant-based proteins, and so if you are a vegetarian or a vegan, you have to eat way more, a wider variety of plant-based matter to be able to get all of those essential amino acids that you need, rather than if you eat meat, you can eat one chicken breast and have all of the essential amino acids in that meat product. However, reducing meat intake while increasing plant intake and trying to get proteins from plants rather than animal matter is going to have some advantages to it. We know that plant materials are going to be harder to digest. They're going to provide more fiber, which is going to help with that digestive functioning. They're going to also provide vitamins and minerals that many meat products will not be able to provide. Plant products also contain less saturated fat, they have no cholesterol, which is going to be better for heart health, and they require less land use than raising animals for consumption, like cows and chickens, things like that. So they're better for the environment. Now, minerals and vitamins, again, these are micronutrients, so these are ones that we only need in small quantities, but they're very important for the physiology of humans. Now, vitamins are very small organic compounds that can be used as coenzymes, so they help the enzymes speed up chemical reactions in the body. And if you have deficiencies of any of these vitamins or minerals, that could be potentially lethal. It could be deadly because these are going to be required, even though they're required in smaller amounts, they're still required for us to stay healthy. Now, minerals, we'll start with minerals. These are chemical elements that plants extract from soil and water and then get introduced into the food web thanks to that. So they make up about 4% of the body's mass. About 3/4 of these minerals consist of calcium and phosphorus that we have stored in our bones and teeth. We know that calcium is going to be essential for a lot of organ systems. Our cardiovascular system needs calcium to function correctly. Muscles need calcium. The nervous system needs calcium. So we want to have a lot of calcium stored in our body at all times. Phosphorus we know is a key structural component of phospholipids, which help make up our cell membranes. as well as ATP. And so we also need a lot of phosphorus available at all times. Now, cofactors are there to enable enzymes to function. And so these minerals often act as cofactors. For example, calcium, iron, magnesium. These are all going to be used as cofactors to help enzymes function properly. We also know that iron is another important mineral that's going to be involved in the production of hemoglobin. It's found in hemoglobin, which helps us bind to oxygen and transport oxygen through our blood. Now, many mineral salts are going to function as electrolytes. For example, sodium chloride we get from table salt. We typically don't have any trouble getting that in our diets in America because there's tons and tons of sodium in most foods in America, especially any kind of processed or preserved foods, are going to have a lot of sodium present. And so the average sodium intake for a person should be about 1.5 grams per day, but in America, it's way over that, over double the daily recommended amount typically, especially if you're eating, again, processed and preserved foods. Now we take a look at vitamins. Vitamins are small organic molecules that we get from food. And again, these are going to serve typically as coenzymes to help enable enzymes to function correctly. So most of the vitamins that we need, we get from our diet. The body can synthesize some vitamins from provitamins. For example, vitamin A can come from carotene, which we can get from certain vegetables. And vitamin K and folic acid, we know, are produced in the large intestine by bacteria as they digest that fiber, those complex carbohydrates. But we know that most of the vitamins that we need are going to come from our diet. So we have some vitamins called water-soluble vitamins. These are ones that absorb water through the small intestinal lining, and they're going to be dissolved in bodily fluids. They get excreted by our kidneys if we have too many of them. And so we do not store water-soluble vitamins. Any excess water-soluble vitamins that we have in the body just get urinated out. Some examples of water-soluble vitamins are going to be vitamin C, which promotes hemoglobin and collagen production. It's also going to aid in connective tissue structure, and it's an antioxidant, meaning it's going to help us to get rid of free radicals in the body. We have vitamin B, which is going to function as a coenzyme, again, to help those enzymes function correctly. And then we also have fat-soluble vitamins. These are ones that are absorbed with lipids from our diet. Some examples of this are vitamin A, which is a component of visual pigment, so it's going to help in function of vision. It's also going to promote epithelial tissue maintenance, and it's an antioxidant. Vitamin D is another fat-soluble vitamin that promotes calcium absorption and helps us strengthen our bones. Vitamin K is another example that is used for blood clotting, and then vitamin E is an antioxidant. Now, if a person has a vitamin A deficiency, this could cause blindness. If it becomes severe enough, especially night blindness, it could cause the skin to be very dry, to increase your risk for infections. And this is the most common vitamin deficiency in the world. Now, if you have too much vitamin A, that can lead to other problems like nausea, headache, having certain breath defects, etc. A lot of times in America, people will take what are called megavitamins, and so these are vitamins that are doses that are 10 to 1,000 times higher than the recommended daily allowance. And there's really no evidence that this is going to improve health unless the person has a severe deficiency in one of those vitamins. Now, we know that megadoses of fat-soluble vitamins can be harmful. It can actually do damage to the liver. And so those fat-soluble vitamins that I listed out, you really want to just maintain a normal recommended daily allowance of those. You do not want to go above that recommended daily allowance.